All right, welcome to another video. Today we're going through the Pure Mathematics Unit 2, Paper 2, and this exam is 2 days from now on Friday. So, we're just going to try to go through this paper really quickly. First question here is from the Marvelous theorem, and it says prove sine 5 theta over sine theta works out to be this expression right here, right? So first thing, let's start by writing down what the Marvelous theorem is. So I have to remember cos theta plus I sine theta raised to the nth power this is equal to cos n theta plus I sine n theta. So in this case, we notice if we substitute n as 5, right? If we substitute n as Alright, so I had some issues earlier, and so on the computer it was not recording with the sound, so as I realized I have to stop here. Can't bother to rework this where it had the issues. We had started question number 2, and we had gotten to this point where the audio wasn't clear and the computer was having some issues. If you're hearing like school bell and stuff like that, I am actually at school, alright, with the noise, the background noise, alright. So pretty much we did what we did, just a recap. First thing we noticed that whenever the power in the denominator and the numerator are the same, so it's improper. So we broke it up into improper, alright, and then we got it as 1 plus 1 over x to the 4 minus 1. Then now we have to remember this, now we need to break it up some more using difference of 2 square. That's why I put the recall. And once you break it up using difference of 2 square, you get your denominators now. And now we're going to do partial fraction, right? Proper partial fraction. And what we did now is we had got our x cubed, x squared, x terms, constants, and now we're going to solve these equations for a, b, c, and d. So I had laid it out here, equation 1 minus equation 3 gives, if you look, a minus a gone, b minus b gone, and then c minus minus c, that give you 2c is equal to, I don't like how this writing, I'm going to switch it. Because I'd see it somewhere here as well. So here, so switching the top. So we had gotten up to this point, so from equation 1 minus equation 3, the a would cancel the a, the b cancel the b, then c minus minus c is 2c, so 2c, so 2c is equal to 0, so c is just 0. Then now we can look at, what about equation 2 minus equation 4? If we look at equation 2 minus equation 4, that's going to give us, and I have to do it this way to save the space. So minus a minus minus a cancel, b minus b cancel, d minus minus d give 2d. So that gives 2d is equal to equation 2 minus 4, 0. Minus 1 is negative 1. So right here we get negative 1, and so d is just negative a half. So we get c is 0 and d is negative a half. Now we need to plug these values into two equations. I'm going to plug c being 0 in. Let's plug it in equation 1. So now we're going to sub c equals 0 into equation 1. Plug it in equation 1, if a plus b is 0. So a plus b is equal to 0. Then I'm going to plug d as negative half in equation 2. So we're also going to sub d equal negative half into equation 2. When I plug it in equation 2, it's going to be minus a plus b. Minus a half is 0. Bring over the minus half, so I'm getting minus a plus b is equal to positive half. All I did, bring the minus half to the other side. So now we have two equations to solve for a and b. We have this equation and we have this equation. So now solving for a and b, let's add these two new equations. So we're just going to put add. Adding them, a plus minus a cancel. B plus b is 2b equal half divided by 2b equal quarter. If b is quarter, so a must be negative quarter. And remember we said the partial fraction is this. So therefore, our final answer is x to the 4 over x to the 4 minus 1 is equal to 1 plus, remember it's a over x plus 1. A is minus quarter, so we can change this plus to actual minus. So this is now a minus 1 over 4, that's a quarter. Then put back a x plus 1. Then right here we have b over x minus 1. B is a quarter, so plus 1 over 4 in bracket x plus 1. Then plus cx plus d. C is 0. 0 times x is 0 plus d. And d is minus half, so minus 1 over 2 times x squared plus 1. That's it. And now right here, you shouldn't write in this margin. So that's it. So that's what they wanted. And we did it. Yep, we did it. Alright. Now the only thing is notice they put the plus first, then the minus. So you would need to reshuffle this a bit. Put the plus here and the minus here. But I'm not gonna reshuffle that. That's a waste of time. So we did the proof. Now it says hence or otherwise determine this integral. I'm gonna go with hence. So integrating x to the 4 over x to the 4 minus 1 dx. Going with the hence, we're integrating this here. So we're integrating all of this using the hence. So we're integrating this expression instead. So it's going to equal to integral of 1 plus 1 over 4 in bracket x minus 1 minus 1 over 4 in bracket x minus 1, x plus 1 I mean, then minus 1 over 2 in bracket x squared plus 1. So minus 1 over 2 in bracket x squared plus 1 dx. So this is what we're integrating for 6 easy marks. Remember you can integrate them separately. So I'm going to break it up as separate integral as integral of 1 dx plus factor out the quarter. That's a quarter times the integral of 1 over x minus 1 dx. Factor out the quarter here, so minus a quarter times the integral of 1 over x plus 1 dx. Factor out the, try to factor out the minus half, it doesn't matter. I'm going to factor it out. Still having some difficulty with this in terms of my writing pad and JC and my school's internet. So factor out minus half times the integral of 1 over x squared plus 1. I'm going to leave off the dx due to space. Alright, so now when you integrate 1, you're going to get x. Now when you integrate 1 over x minus 1, you get ln, so that's plus a quarter ln x minus 1. Then when you integrate 1 over x plus 1, that is ln x plus 1. Then when you integrate 1 over x plus 1, that's tan inverse. So this is minus a half tan inverse of x plus a constant of integration. Right? So I'll call my constant of integration plus, come on pen, stop disappearing, plus j. Now I don't like how this looks. I can leave it as the integral of x to the 4 over x to the 4 minus 1 dx. I will write this as x. Alright, so continuing this paper, and so we had x plus ln. We can bring up the power and realize that we're subtracting laws of logarithm, so it becomes x minus 1 over x plus 1. Bring up the power of quarter. So this is all raised to the quarter. And then we have, of course, our minus half tan inverse of x plus our constant of integration j. And that's it. That gives you 6 marks. Very easy. All right. And no problem. All right. Now, part B, right here, it says we're supposed to show that in will give us this right here. Alright, so we know that this is an integration by parts, or some like to call it row reduction involving integration by parts. Right, so of course you have to remember the rule late. Remember that algebra comes before exponential functions. This is going to be your u, and this is going to be your dv. So in that case, u is equal to 1 minus x, and we're raising it to the nth power. So du is carried on the power. We subtract 1 from the power. Then we multiply by, of course, the derivative inside the bracket, which is negative 1. So du is just negative n in bracket 1 minus x to the n minus 1. Then dv is e to the ax, and so v is equal to the integral of e to the ax, which is e to the ax divided by a. Now we're going to write down Eilate formula. We know Eilate formula tell us that. Let's write it here. The integral of u dv is equal to uv minus the integral of v du. That is Eilate formula, right? That's what it reduces to when we're doing integration by parts. So in this case now we're telling them that the integral, I can't bother write integral, let's write the word in. So in is equal to u times v, u times v, which is e to the ax over a times 1 minus x to the n minus the integral now of v times du. But you notice that because it's a minus and this is a negative, it's going to become plus. So it's plus the integral of, we're going to multiply v times du. Now n times all of this, we can just put the n. Instead of putting n over a, we're going to put n over a here. Then now we have, of course, 1 minus x to the n minus 1 times e to the ax dx. Then now we're just going to finish this off now. So finishing this off, put it in the form that they want it. So we have to put 1 minus x to the n first. That's how they have it, right? You look, that's how they have it, 1 minus x. Oh, actually they have 1 over a. So we need to factor out 1 over a. Write it how they want it, please. 1 over a, 1 minus x to the n times e to the ax plus n over a. And this right here is, notice this is now, because it's raised to the n minus 1, this is in minus 1. This is in minus 1. That will prove what they want. We'll finish. How much marks for this? I would give this 4 marks. How much they gave? They gave 5. So they gave 1 more than what I would give. And again, if it's a little bit noisy, just bear with me. As I said, I'm at school, and of course, school is in session, and right now it's actually lunchtime. Alright, so you know that is when it's lunchtime. It's going to be a little more noisy. Now here it wants us to hence integrate this function. Hence meaning using the formula that you just derived. Now the formula we just derived is this now. You realize that right here it's 1 minus x raised to the third power. So we're going to substitute n as 3. And realize e to the ax, we're going to substitute a as 2. So just to write it back down what we had. So I'm just going to write it at the top. Recall that the integral of 1 minus x to the n, e to the ax, e to the ax. Recall that 1 minus x to the n, e to the ax, dx. Remember, it's equal to, so recall that it's 1 minus x to the n. So I had to relocate again. So there was a class in that room, so I had to move. So that's why, the video would have paused. I would have noticed a little. I'm gonna make sure to edit it proper. Alright, so going back to what we had said earlier. Alright, the integral of 1 minus x to the n e to the ax, we had just derived it is 1 over a in bracket 1 minus x raised to the nth power times e to the ax plus, then it's in minus, well, n over a times in minus 1. So all we're really doing now is basically just substituting. So we're going to substitute. If you notice, if you let n equal 3 and you let a equal 2, then that is all we're working out then. Remember this, they call it in. So what we're really working out then would be I3. This is the formula for in. So what we're working out now is I3. And I3 then will be, formula says it's going to be 1 over a. So 1 over a is 2. Right? So put in this n value as 3, and this a value as 2. Right? And then we get what we want down here. So I3 is what we're working out. I3 is 1 over a times 1 minus x to the n. So 1 minus x to the third power e to the ax, which is 2x, plus n, which is 3 over a is 2 in bracket, in minus 1. And 3 minus 1 is I2. Now we need to work out I2. So this is now half 1 minus x cubed e to the 2x plus 3 over 2 times I2 mean you're going to have to put n now as 2 in this formula. If you put n as 2 in this formula, this become 1 over a is 2 times 1 minus x to the n is now 2, e to the 2x plus n is now 2, 2 over 2 is 1. I'll put the 2 over 2 so we can follow n is 2, a is 2. Then we'll put I to the 2 minus 1, but 2 minus 1 is I1. Now we need to go again. There's so much steps to doing just to find I3. Man, that is fun, right? So now my pen stop right here. Alright, so now we have half 1 minus x all cubed e to the 2x plus if we multiply it by 3 over 2, that's 3 over 4, 1 minus x, and this is being squared e to the 2x, then this is really 1, so now we have plus 3 over 2 times I1. This is 3 over 2 times I1. But now we need to find the value of I1, so I'm going to take off this I1 now. We know it is I1. We're going to plug n now as 1 in the formula. In the formula, if we plug n as 1, this becomes 1 over a, so 1 over 2, then 1 minus x to the first power. I hope the background noise is not that bad because, as I said, it's lunchtime, so please just bear with the background noise. Alright, so n is 1 here, so we'll put 1 minus x to the 1. E to the ax, this is 2, so e to the 2x plus n over a, so now this is plus 1 over 2, then 1 minus 1 is 0, so now this is I naught. Now we can find I naught easily. I naught, I'm just going to write I naught up here, right, just to save space. I naught would be the integral of 1 minus x to the 0, e to the 2x, but anything to the 0 power is 1, so when you integrate e to the 2x, that's e to the 2x over 2. So that is I naught. So we're going to put that in the next line now. This becomes now half 1 minus x cubed e to the 2x plus 3 quarter 1 minus x squared e to the 2x plus 3 times 1 is 3 over 2 times 2 is 4. 1 minus x times e to the 2x. Then 3 over 2 times 1 over 2 is 3 quarter. And it's 3 quarter of I naught, and I naught is e to the 2x over 2. So your final answer is 1 over 2, 1 minus x cubed e to the 2x plus 3 quarter 1 minus x squared e to the 2x plus 3 quarter of 1 minus x e to the 2x plus this is now 3 over 8 e to the 2x. Now if you want, you can make your answer look pretty. No, 5 marks don't make your answer look pretty, alright? I was gonna say factorize it because it looks lovely when you factorize. And you know what, just for the fun of it, I will factorize. So if you were to factor out, notice this is really, I'll change half, and half is really 4 over 8. I'll change this to 6 over 8, and I'll change it to 6 over 8. That way we can factor out what they have in common is at least 1 over 8. I can factor out 1 over 8. And notice all of them have a, well, not all of them have a 1 minus x. So I'll factor out 1 over 8 e to the 2x. And then that will lead me back with, from this side I have 4 in bracket 1 minus x cubed. And this would have plus 6 in bracket 1 minus x squared. Then I factor out from this side of plus 6 in bracket 1 minus x. Then I factor out 1 over 8 from this, I leave back with plus 3. So all I did was factorize it because this look a little bit prettier. But you don't need to factorize. I just did it because I think factorization is fun. And that finished question 2. Again, guys, I'm so sorry for the breakage. I start number 1, then number 2, the question, it wasn't recording the audio. Then I had to stop it again because I had to change location. I'm sorry about that. And also sorry for just posting the solution, all right? Remember, still have classes, still have extra classes after school and other commitments. And so I really hope this video is going to be helpful, even though it's very last minute. All right, now this question is a proof by mathematical induction, and they want us to prove this right here. By the way, this cannot be valid for n greater than or equal to 1, because 1 minus 1 is 0. So this is wrong already. All right, so this is wrong already, so it's valid for n greater than 1. Not greater than or equal to 1. It cannot be valid for 1. It cannot be valid for 1. All right, so you're going to have to realize that we're going to have to start from n equal 2. So let n equal 2. All right. If we let n equal to, by the way, I like to derive though. This is the summation formula for it. All right. So this is really the sum from r equal 1 to n of 2r minus 1 over r squared in bracket 1 minus, well, r minus 1 all squared. All I do is change n to r. And they say it's equal to 1 minus 1 over n squared. Now, if you notice, you cannot put in 1 because if you put r as 1, you divide it by 0, which don't make no sense. So, we have to start. So, for step 1, we have to start at n equal 2. So, your left hand side is going to be put in r as 2. Put in r as 2, this is 2 times 2 minus 1 over 2 square in bracket 2 minus 1 all square. 2 minus 1, 4 minus 1 is 3 over 2 square is 4 times 2 minus 1. 2 minus 1 is 1, so that's 1 square, which is 3 over 4. Notice you get the first term, and it started at 3 over 4. Then now your right hand side is going to be 1 minus 1 over 2 square, which is 1 minus a quarter, and 1 minus a quarter is 3/4, right? So that is step 1. Now for step number 2, you let, oh, right, therefore n equal 1 is true. For step number 2 now, let n equal k. So when we let n equal k, we have the sum from r equal 1 to n of 2r minus 1 over r squared in bracket r minus 1 all square, and we said let n equal k. So now where that n is, we put the letter k. Now once you put the letter k now, this is what we have. Alright, it's equal to now 1 minus 1 over k squared. And we assume true. Assume true. Alright, now step number 3. So for step number 3 now, alright, is let n equal k plus 1. So for n equal k plus 1, we have the sum from r equal 1 to k plus 1 of 2r minus 1 over r squared in bracket r minus 1 all squared. That is going to be equal to the sum from 1 to k of 2r minus 1 over r squared in bracket r minus 1 all squared plus the k plus 1 term. Now, I love when you write this down. Always write down what you're required to prove. Your final answer should be 1 minus 1 over k plus 1 all squared. That's what our final answer should be. We should somehow let all of this work out to be what we're trying to prove here. So in that case, continuing step 3. So we're going to write step 3 continued. So we're saying that the sum from r equal 1 to k plus 1 of 2r minus 1 over r squared in bracket r minus 1 all squared is equal to the sum from 1 to k. The sum from 1 to k in the line above was 1 minus 1 over k squared. So 1 minus 1 over k squared plus the k plus 1 term. And the k plus 1 term is, we input where r is k plus 1. So where r is, we put k plus 1. So that is 2 in bracket k plus 1 and we subtract 1 over where r is, we put k plus 1. That's k plus 1 square in bracket k plus 1 minus 1. K plus 1 minus 1 is k, so that's k squared. Then now we simplify this guy right here. That's 1 minus 1 over k squared. Then this part is 2k. That's 2k plus 2 minus 1. And 2 minus 1 is just plus 1 over k plus 1 all squared times k squared. Remember 1, by the way, look what I'm going to do. I'm going to rewrite this 1. 1 is the same as k squared over k squared. Why did I do that? Because, well, let me not even do that. I was going to try to have some fun, but let's not even do that. Keep it as 1. Yeah. So now, right here, now we're going to find the LCM among these two terms. So I'm going to just flip it around. I don't like negative coming first. Guys, try to keep the negative as the last term, alright? So I'm just flipping it around. Put the plus them first, then the minus after. It just looks better that way, right? Now I'm going to find the LCM among these last two terms, which is k plus 1 all squared times k squared. That leaves 2k plus 1. Listen to this, leave k plus 1 all squared, so I'm subtracting. Times this now by the k plus 1 all squared. So I'm subtracting k plus 1 all squared. Then remember at the front is 1 minus that. So now we're getting, this is now 1 minus, this numerator becomes, let me put a bracket around it, remember this is what we're subtracting, 2k plus 1 over, when we're subtracting, remember this is k squared, so when you subtract k squared, it becomes minus k squared. The middle term would be 2k, but you're subtracting it, so it's minus 2k. Then this term is 1, and you're subtracting it, so it becomes minus 1 over k plus 1 all square k squared. Then now continuing, I notice, wait a second, 2k and minus 2k gone, plus 1 and minus 1 gone. So you're just going to tell them this is now 1 minus, this leave minus k squared, so 1 minus in bracket, that leave minus k squared over k plus 1 all squared times k squared. But then as we notice, the k squared is going to cancel. K squared, change the color and show you the cancellation. The k squared cancel the k squared, leave just negative 1. Then minus and minus, well, I have a minus there. But shouldn't it be 1 minus? Should there be a minus here? Because the final answer said we're required to prove that it should be 1 minus 1 over k plus 1 all squared. So I have a minus. So this is minus k squared minus 2k, then minus 1, and then minus and minus. I am getting this should be 1, minus and minus is plus. Getting this would be the answer we're supposed to get, but for some reason this and this would be a plus. So I'm trying to see where I made any small error. This is absolutely fine. 2k plus 1. I put this in front and put minus over there. That's very, oh, here's the mistake. This would have now been a plus. This would have been a plus. Now it is minus here. This would have been a plus, so here is a minus. Here. So that was a small mistake, and therefore, and you can go, let me zoom out so you can actually take a screenshot or something of the solution. You'd actually see it's okay. I zoom it out. So right there, you'd actually see, therefore, step 3 is true. Therefore, n equal k plus 1 is true. And then never forget to write your conclusion. Always write your conclusion. Then you're going to write by PMI. I don't have any space. I'm just going to say the statement is true. Statement is true by PMI, right? Because I don't have any space, guys. I hope you understand. Now, right here it says hence or otherwise calculate S30 minus S10. So we need to work out S30 minus S10. So this is the summation, right? Remember, that was the summation. So we had just proved a while ago the sum from r equal 1 to n of 2r minus 1 over r squared in bracket r minus 1 all squared. We derived that this was 1 minus 1 over n squared. So in that case now, to actually show them now by the hence, using the hence now, so that means this is Sn. So that means S30 is just equal to 1 minus 1 over 30 squared. And that's 1 minus 1 over 900, which is 899 over 900. And then S10 is going to be 1 minus 1 over 10 squared, which is 1 minus 1 over 100, which is 99 over 100. So finally we can tell them S30 minus S10 is 899 over 900 minus 99 over 100, which is, I put that in the calculator because I really cannot bother to do that subtraction mentally. It's actually quite a bit. Subtract 99 over 100. That should be 2 over 225. That's your answer. Now, this was using the hence. This was the hence method. You know my style. I love to show otherwise, even though it's not good to do both ways because you want to finish time. The otherwise would be you just put it in the calculator. Otherwise, it's just telling them S30 minus S10 is equal. They can't stop you from doing this. You can do this. It's the sum from r equal 1 to 30 of 2r minus 1 over r squared in bracket r minus 1 all squared minus the sum from r equal 1 to 30, 1 to 10 I mean, of 2r minus 1 over r squared in bracket r minus 1 all squared. We're going to use our calculator. So you're showing them that you understand what you're doing. Using a calculator, you put in summation from 1 to 30 of fraction button 2r or 2x for our purpose minus 1 over x squared now times right here now is x minus 1 all squared. We're punching that in. What did I not do? 1 to 30 of 2x minus 1 over x squared. Yeah, putting everything right. Saying math error. 2x minus 1 of x squared. We type it over. 2x minus 1 fraction button 2x minus 1 over x squared, and this is then multiplied by x minus 1, close the bracket, and then we square it. I guess we had to do it the hence because the calculator clearly, guys, unfortunately You have to use the hints because as you can see, the calculator can't work it out. I thought this calculator was better than this. Yeah, it can't work it out. The calculator can't do it. So yeah, I guess you could have used method of differences, but we don't have time. So just to write this down, this is what it would actually work out to be. Then you work it out and get the same 2 over 225. But clearly the calculator can't do it. Now guys, I'm gonna have to move one more time because why? My phone battery, my computer battery is absolutely dying. Oh boy. Sorry guys, so much up and down. Alright, so just bear with me. I'm gonna pause the video and continue. Let me move. Alright, so I move now, so now I'm able to continue. Then it says calculate the sum to infinity of this right here. Alright, so continuing the paper from yesterday, and I'm gonna edit it up nice because you notice, I had a lot of stoppage yesterday at school, but we're gonna finish this paper for those getting ready for exam tomorrow. So this one they ask to calculate the sum to infinity of this series right here. Now, let's say you don't know sum to infinity, right? And if you don't know sum to infinity, that's fine. You can just plug in and get an idea of what is happening. So if you plug in and get an idea of what is happening, you plug in from r equal to, so you get 10 over 2 square minus 1 plus 10 over 3 square minus 1 plus 10 over 4 square minus 1 plus 10 over 5 square minus 1, and it continue and it continue and it continue, right? Until you put in the last term. So this right here, right, you add up all of these and you get a sum to infinity, but we can't just add these up, alright? We can't. Why? Because if you look at it, I want to list it out for you why. If you look at it, this is really 10 over 4. 2 square is 4, 4 minus 1 is 3, plus 10 over, this is now 8, then 10 over 16 minus 1 is 15, then 10 over 24, and you catch a pattern. You keep adding, so you add 5, then 7, then 9, so the next one would be add 2 to 9, that's 11, so it would be 35. Then you add 13, it would be 48, and so forth. Now we cannot deduce the pattern for this to evaluate. So when we can't evaluate the pattern, you have to think back, how can we evaluate this sum to infinity then? And the first thing that should come to your mind is what we call method of differences. With method of differences now, what we're going to have to do is we're going to have to break this up. So we can say, okay, 10 over r squared minus 1 is equal to a over r plus 1 plus b over r minus 1. That is what we do now. So break it up using partial fraction. That's what we're going to do. Right here, the LCM is r plus 1 times r minus 1. R plus 1 into this leave r minus 1. So we have a times r minus 1 plus r minus 1 into this leave b times r plus 1. That's equal to 10. So now we can, of course, equate the numerator. Equate the numerator, 10 is equal to AR minus A plus BR plus B. So notice there are no R terms. So equating R terms, we see that 0 is equal to A plus B. And equating our constants, we notice that 10 is equal to minus A plus B. So now we can go ahead and just add these two. If we add the two equations, we're getting 10 is equal to 2b, therefore b is equal to 5. And once you get b is equal to 5, then therefore b is 5, a is now negative 5. Now that we get it as method of now that we get the two fractions, we can now say, well, so that means now we can do the sum to infinity. We can say the sum to infinity, which is the summation from r equal to infinity of 10 over r squared minus 1. We can say this is now equal to the sum from 2 to infinity of Break it up now. A over r plus 1, then b over r minus 1. I'll start with the positive one first. 5 over r minus 1. Then minus, because a is a negative, 5 over r plus 1. So this is what we're evaluating. So now we can use the method of difference formula. And this case, we're going to observe. If we plug in the 2, 2 minus 1 is 1, and 5 over 1 is 5, plus plug in the 3, that's now 5 over 2, and plug in the 4, that's 5 over 3, and then 5 over 4, and it continues. And the last term, well, don't need put in all the way up there, right? Minus, now we're subtracting down here now, so we plug in 2, this is 5 over 3 plus, sorry, then we plug in 4, that's 5 over 4, and 5 over 5, and we continue to plug in the last term. Now what we notice is a lot of cancellation is going to take place. So notice 5 over 3 cancel, 5 over 3, 5 over 4 cancel, 5 over 4, 5 over 5 cancel, 5 over 5, and everything else pretty much cancel. And so what is left is 5 plus 5 over 2, and that is 5 plus 2.5 is 7.5. So you can give them an answer as a decimal and say 7.5, or you can say 15 over 2. Whichever you give is absolutely fine. Alright, so that would be this right here. 7 easy marks. Not bad at all. Alright, that's that. Now, this part now, they said determine the Taylor series expansion for this function x sine x over 2 about the point where x is equal to pi, and they want the first three non-zero term. Alright, notice they put it in bold. Only three terms. So the first thing I like to do is to write out the Taylor series formula. Remember, f of x is equal to f of a plus f prime of a times x minus a plus f double prime of a times x minus a squared over 2 factorial plus f triple prime of a times x minus a cube over 3 factorial. That's the formula. And so now we need to evaluate f of a first. Alright, so notice our function f of x equal to x sine x over 2. So which means f of a, which is f of pi, or a in this case is pi. So f of pi is equal to pi sine pi over 2, and make sure your calculator is in radians. So you put in pi sine pi over 2, even though we know pi over 2 is 1, but just to put it in the calculator anyways, right? Just for safety, no problem, radians, plug it in, so we get pi. So this is now pi. No need to differentiate this function. We're going to have to use product rule. So f prime of x is equal to keep the first times the derivative of the second. When you differentiate sign, you get cos x over 2. Then you multiply by the derivative of x over 2, which is half. So I'll just put that right here. Plus, keep the second, sine x over 2 times the derivative of the first. But when you differentiate x, you just get 1. Now we can work out f prime of pi. F prime of pi, you put pi right there. We know the cos. Cos pi over 2 is 0. Cos 90 is 0. So this would be pi over 2 times cos pi over 2 is 0 plus sine pi over 2 is 1. So notice we get 0 plus 1 is just 1. And finally we need f triple prime, well f double prime, sorry, of x. So we're going to have to differentiate this now. Now we're going to have to use product rule again. Keep the first times the derivative of the second. When you differentiate cos, you get minus sine x over 2. Then you multiply it by half. Plus keep the second, cos x over 2, multiplied by the derivative of the first. The derivative of the first is half. Alright? Then now when you differentiate sine x over 2, you get cos x over 2, and then you multiply it by half. So just to make sure you did it right, keep the first, differentiate the second, good, plus keep the second, differentiate the first, then we differentiate sine x over 2. So I'm just going to simplify this expression. So f double prime of x, simplifying the expression, half times half is a quarter, so that's quarter, and then we have the x in the numerator, and we have a negative here, so we can write minus a quarter x sine x over 2, then we have plus, this half times x over 2 is quarter cos x over 2, then we have of course plus half cos x over 2, right? So therefore f double prime of pi, you know that sine pi is 1, so this right here is minus a quarter, x is pi, and sine pi over 2 is 1. Then now cos pi over 2 is 0, cos pi over 2 is 0, so f double prime of pi is just minus a quarter pi. Now we can write down the function. So what's going to be the function? Using what the formula now? F of x is equal to f of a. F of a is pi plus f prime of a, and f prime of a we got was 1. So this is 1 times x minus a. So plus 1 in bracket x minus a, which is pi, plus f double prime. F double prime is minus a quarter pi in bracket x minus a squared, so x minus pi squared, and we divide it by 2 factorial. This is our answer. Now you can always simplify this, alright, but you're not getting any extra mark to simplify. If you want, you can always simplify pi plus x minus pi, then a quarter divided by 2 is 1 over 8, so you can write minus 1 over 8 pi in bracket x minus pi squared. That's it simplified. But you're not getting any extra marks to simplify it, so don't waste your time. Please, don't waste your time. That's this question here. Nice. And that complete question number 3. Now question number 4, right? They show that the binomial expansion of 1 plus 5x to the 1 over 5, it should be worked out to be this right here. The first thing is, right? First thing is we have to remember the binomial expansion formula for 1 plus x to the n. 1 plus x to the n is 1 plus nx plus n times n minus 1 x squared over 2 plus n, stop it, n times n minus 1 times n minus 2 x cubed over 3 factorial. Remember, this is the formula we use. In this case, though, you notice your x is 5. Your x is 5. So in that case, now it is 1 plus 5x, and n now is 1 over 5. It's equal to 1 plus n. N is 1 over 5. So we have 1 over 5 times x. X is 5x plus n again is 1 over 5 times 1 over 5 minus 1 is 1 over 5 minus 1. I'll put in the calculator. 1 over 5 minus 1. That's negative 4 over 5. Multiplied by x squared, which is 5x squared over 2 plus. This is now n times n minus 1. That's 1 over 5 times minus 4 over 5 times n minus 2 now is 1 over 5 minus 2. I think that's minus 9 over 5 times 5x, and that's being cubed divided by 3 factorial 6. Now you can just put it in your calculator, right? So put in a calculator 1 over 5 times 5, put that in a calculator, you should just get x. This part, put it in a calculator, alright? Put in a calculator, see it here. This is just calculator, guys. Just 1 over 5 multiplied by negative 4 over 5 times 5 squared. Notice we get negative 4. So this is minus 4x squared over 2. In the next part now we have plus. And now we're going to work out the next part now, which is whole power working as well. 1 over 5 times negative 4 over 5 times negative 9 over 5 times 5 cubed. Put that in the calculator, and all of this work out to be 36. 36 divided by 6, and of course we put our x cubed. Go ahead now, do the division, and you get their answer. 1 plus x minus 2x squared plus 6x cubed. Do a question like this, you tell them, easy, easy 6 marks. You take it. That's it. Because they just wanted us to prove that, and you just use the formula and you get your 6 marks. It's nothing challenging. Now it says by letting x be minus 1 over 32, compute an estimate of the fifth root of 27. So look at what we have. First thing, start with what we have, right? We have 1 plus 5x to the 1 over 5, and we said that this is 1 plus x minus 2x squared plus 6. And then they told us to let x be negative 1 over 32. So let x equal negative 1 over 32. So in that case, this becomes 1 plus 5 times negative 1 over 32. And remember, 1/5 means the fifth root anyway. So we can just put raised to 1 over 5. That's equal to 1 plus negative 1 over 32 minus 2 times negative 1 over 32 squared plus 6 times negative 1 over 32 cubed. Now you're just going to put that into your calculator. It's just a matter of calculator now. 1 minus 1 over 32 minus 2 times in bracket negative 1 over 32. Then you square it. Then you have plus 6 times negative 1 over 32. And then you cube it. Plug that in and we get this right here, 0.9666, whatever that is. I'm going to write 0.966613. I'll stop there for now, all right? And then, of course, right here, we need to evaluate this part now. We notice what we're getting, left side, the 1 plus 5 times negative 1 over 32. And in the calculator, you notice we get 27 over 32. Notice right here, we're getting 27 over 32. The fifth root of it is this. Remember, you can rewrite this now as the fifth root of 27 divided by the fifth root of 32. But the fifth root of 32 is just 2. That's equal to 0.9666137. If we cross multiply, that means that the fifth root of 27 is equal to 2 times this, cross multiply. So you're just going to cross multiply and put now 2 times 0.9666137. I'll put that in the calculator, and that's 1.93. That's our approximation, 1.93. And you can always check and see if you're okay. So check it out. Fifth root Alright, so we want the fifth root of 27, and let's see how much it gives us. 1.93, just like what we get. So we know our answer solid. Once you double check it and you know your answer solid, just tell them, okay, that question was nice. So we're gonna write soft. Finish your question and tell them soft. Alright, so that's that right there, 1.93. Alright. Now the next part of the question, part B, is always going to be intermediate value theorem, bisection, linear interpolation. That's the next part, right? It says prove that this has an interval, a root on the interval 0, 1. So first thing is, let's call this function f of x. Let f of x equal to 4e to the x minus, well, plus 2x squared minus 5. Now f of 0 is going to be 4e to the 0 plus 2 times 0 squared minus 5, which is equal to 4e to the 0 is 1. 4 minus 5 is negative 1, which is less than 0. Put in f of 1 now. F of 1 is 4e to the 1 plus 2 times 1 squared minus 5. Then you put that in a calculator. 4 times e, what get e? E plus 2 times 1 is 2 minus 5. Notice we get 7.87. This is 7.87, and that is, of course, greater than 0. So in that case, if you were to sketch like a graph, right, you will notice that when the function is 0, the y value is negative 1. When the function, the x value is 1, the corresponding y value is 7.87, right? If you were to draw now a continuous curve, don't know that curve like a frown or a smile, so I'll just draw like a curve like this. But we do know that the root would be 0 here, the root is between 0 and 1. So we can conclude thus by IMVT there exists a root on the interval 0, 1. That's it. Done. Easy 3 marks. Okay. On the next part, they want us to use using using 4 iterations of the interval bisection method. We need to calculate an approximation of the root. So we need to use the bisection method. Right? So the first thing we need to find the midpoint. I like to call midpoint xm. 0 plus 1 divided by 2, that's 0.5. Then we need to evaluate f of 0.5, which is plug in 4e to the 0.5 plus 2 times 0.5 square minus 5. That in a calculator, we have no issues using calculator. 4 times e raised to the 0.5 plus 2 times 0.5, 2 times 0.5, and it is being squared minus 5. Within the calculator, we notice we get 2.09. So when we get 2.09, that's greater than 0. Alright, so we get 2.09, which is greater than 0. Since this is greater than 0 and 0 was less than 0, what we can conclude is that the root lies on 0 and 0.5. Right? Cool. Now remember, this was just one bisection. Let's say do it 4 times. Second bisection now, xm is what average 0 and 0.5 now. xm now, or xm2, xm1, xm2 is 0 plus 0.5 divided by 2, which is 0.25. We'll work out f of 0.25. That's 4e to the 0.25 plus 2 times 0.25 squared minus 5. So change this now to 0.25, 0. What is going on? 0.25, 0.25. Notice we get 0.26, so we're getting closer. This is 0.26, which is still greater than 0. In that case, the root lies on 0 and 0.25. Now, third bisection now, xm3 is going to be 0 plus 0.25 divided by 2, 0.125. So in that case, now we need to work out f of 0.125. Just plug it in the calculator. You don't need to show them so much. Right? Just plug it in the calculator now. 0.125 0.125, 0.125. We get negative 0.436. Negative 0.436, which is less than 0. Now notice this one is greater than 0 and this one is less than 0. So that means the root is going to lie now on the 0.125 and the 0.25. In that case, we're going to tell them lies on 0.125 comma 0.25. But they say use 4 iterations. So this is the fourth one, xn4 equal to 0.125 plus 0.25 divided by 2, and then 0.125 plus 0.25 divided by 2, that is equal to 0.1875. In that case, that is our approximated root. So we're going to conclude approximated root equal to 0.1875. That's it. Easy. Alright, so based on our sketch, we could actually conclude it would have been somewhere about 0.2 based on our little sketch here. Alright, but that is the actual working now, and we're okay. 0.1875 is the approximated root. Alright, that's it. Nice. Alright, the next question says, right here, use linear interpolation method to approximate the root this interval. There's another root, right, in between -2 and -1. I need to use linear interpolation. So the first thing I'm going to do is work out f of -2. Remember, I define the function as f of x, right? Yeah, they should be fine with me calling it f of x. Right, so this is now 4e to the -2 plus 2 times -2 squared minus 5. Punch that in the calculator. 4e. Well, I mean, I was just doing this to actually test out which one is negative and which one is positive first. Right, so 4e, e right there, 4e to the -2 plus 2 times -2 squared minus 5. So punch that in the calculator and we'll get 3.54. 3.54, which is greater than 0. And if we work out f of -1 now, to change that to just -1. Punch that in the calculator and we'll get -1.52. -1.53 actually, which is less than 0. Good to go now. Now remember the interpolation formula. I'll put it right here. Remember the formula is alpha is equal to A times the modulus of f of b. A times the modulus of f of b plus b times the modulus of f of a over the modulus of f of b plus the modulus of f of a. So in that case now we're going to call it alpha 1. Alpha 1 is equal to A, which is -2 times the modulus of f of -1, which is the modulus of -1.53, plus b, which is -1, times the modulus of f of 2, which is 3.54, divided by the modulus of -1.53 plus the modulus of 3.54. And you punch that into your calculator. -2 in bracket -1.53, but then modulus makes it positive, so it's just 1.53. Then -1 in bracket 3.54 over 1.53 plus 3.54, which is -1.30. This is -1.30. Now we need to check f of -1.30. Alright, so take f of -1.30. Now this is 4e Why I can't get the E? And E, 4e to the negative 1.3. Then we have plus 2 times negative 1.3, and that's being squared, minus 5. We notice that f of negative 1.3 is negative 0.53, which is less than 0. In that case, the root lies on, remember it lies on the positive and the negative. So the positive is a 3.54. Then the negative is this, so it lies on minus 2 and a minus 1.3. So that's where the root lies in this particular interval. So now all we need to do now is do linear interpolation 2 more times. So yeah man, you probably start to get a little tired, but no problem. You drink your water, you're ready again. So now this is negative 2 times the modulus of f of negative 1.3, which is minus 0.53, plus negative 1.3 times the modulus of 2 now, which was 3.54, over the modulus of negative 0.53 plus the modulus of 3.54. Remember, modulus makes it positive when you put it in a calculator. You have negative 2 in bracket, negative, well, 0.53 now, plus negative 1.3 times 3.54 over 0.53 plus 3.54. We'll do that and we get negative 1.39. Negative 1.39. Then you'll freeze a bit. Is it back up? Not yet. Alright, so negative 1.39. So now we just need to plug this in now. So f of negative 1.39 is equal to, put it in the function again. Remember the function is 4e to the negative 1.39. Then we have plus 2 times negative 1.39. That is being squared. Then we subtract 5. That is negative 0.139. Negative 0.139. And that is less than 0. Since this is less than 0, then the root lies on negative 2 comma negative 1.39. So now in this case now, almost finished. Last one, alpha 3. Negative 2 times the modulus of f of b. F of b, which is this f of this function, which we just said was negative 0.139, plus a, well, plus b now, negative 1.39 times the modulus of, we had it was 3.54 over modulus of negative 0.139 plus modulus of 3.54. Now alpha 3 is equal to, put it into our calculator, minus 2 in bracket 0.139, then we have minus 1.39 bracket 3.54 close the bracket, then we have minus 0.139, but modulus makes it positive, plus 3.54. And we input this into our calculator and we get negative 1.41. So that's our approximated root. So that's it now. Our approximated root is negative 1.41. You can write it here. Approximated root is negative 1.41. Alright, that's it. Tell them that was nice. Alright, that was a nice question. That wasn't too bad. Now into module 3. Module 3 is the best module because it involves matrices, differential equations, and the probability. So Usually this is the easiest module. Alright, it's the easiest module. So question 5, show that determinant of P is 183. I think this is straightforward. I'm going to be using row 1. So using row 1, determinant of P is equal to the row I'm using. So you cross out the row and the column with 4 in it, like this, right? And so it is 4 times 4, 15, 10 minus 3, right? Then now we cross out the row and column with 3 in it. So minus 3 times 9, 15, 12, negative 3. Then cross out the row and column with 5 in it. So plus 5 times 9, 4, 12, 10. Then it's just calculator here now. So now we just use calculator. 4 times negative 12 minus 150 minus 3 times negative 27 minus 12 times 15. Whoa, 12 times 15. I think that's 180. Just to double check. 12 times 15. Then plus 5 times 9 times 10 is 90. Minus 12 times 4 is 48. Now we'll punch all of this in the calculator. So 4 in bracket minus 12 minus 150. That's negative 648. Minus, well, it almost be minus. It could be plus. Let's see, negative 3 in bracket negative 27 minus 180, that's positive 621. Then we have plus 5 times, well, don't put 5 times, 90 minus 48, they will multiply it by 5, that's positive 210. Then now all of that in the calculator now, negative 648 plus 621 plus 210. That's in the calculator and we'll get the 183. Easy. How much marks? Hopefully 4. Please be 4. Yes, 4 easy marks. So determinant of P is 183. Can tell him quite easily done. Easily brushed aside. Nice. Alright, the next part says hence show that the adjoint of P is this right here. Hence or otherwise. We're gonna go with the hence. So first thing before we find the adjoint, we need to find the cofactor. So to find the cofactor, right? So call it cofactor of matrix P. Remember you draw a big bracket like this, right? Remember to put your cofactor signs plus, then minus, then plus, then minus, then plus, then minus, then plus, then minus, then plus. After you put your cofactor signs, you work out the determinant of each. So cross out the row and the column with 4. You have 4, 15, 10 minus 3. 4, 15, 10 minus 3. Then we'll look at 3 here. Cross the row and the column. We have 9, 15, 12 minus 3. So 9, 15, 12 and minus 3. And cross the row and the column with 5. Right? So we have 9, 4, 12, 10. 9, 4, 12, 10. And cross the row and the column right here with 9. We have 3, 5, 10 minus 3. Then we'll cross the row and the column with 4 in it right here. That would be 4, 5, 12 minus 3. We'll cross the row and the column with 15. We have 4, 3, 12, 10. 4, 3, 12, 10. Then we cross the row and the column with 12 in it. We have 3, 5, 4, 15. 3, 5, 4, 15. Then cross the row and the column with 10 in it. And that's how you're going to be flipping the page back and forth in it. Cross the row and column with it with 10. We have 4, 5, 9, 15. 4, 5, 9, 15. Then we'll cross the row and the column with negative 3. We have 4, 3, 9, 4. 4, 3, 9, 4. Now we can go ahead and evaluate cofactor P. I'm not going to be showing a crazy work. This is just easy. Negative 30. Use a calculator, right? Negative 30. Because 4 times minus 3. Can't even show them the full working. 4 times minus 3 minus 10 times 15. put that in a calculator straight away. Negative 162. Then right here, so now work out the next one. 9 times 15. Well, 9 times negative 3. Then we minus 12 times 15. Remember, the negative and the negative make it positive 207. Then 9 times 10 is 90. 90 minus 48. I don't know, put in the calculator. 90 minus 48 is 42. 3 times 9 minus 9. So minus 9. Then we subtract 10 times 5 is 50. And then the negative make it positive. So we put positive 59. 4 times 3 is negative 12. So we have negative 12 minus 60. So that's 5 times 12. Minus 72. Then right here now 4 times 10 is 40. 40 minus 36 is 4, but then that's negative 4. Just a double check. 40 minus 36, that's 4, then negative 4, yeah. And 3 times 15 is 45. 45 minus 20. 45 minus 20. It's a shame I'm using the calculator for 45 minus 20. That's 25. Then 4 fives. 4 times 15 rather is 60, and then we subtract 9 times 5, that's 15, but negative 15. Then now 4 times 4 is 16, and then we subtract 9 times 3, which is negative 11, so that's minus 11. That's cofactor P. Now once you get cofactor P, you need to find the adjoint. So remember the adjoint, you're going to exchange or interchange row and the column. So therefore, the adjoint of P is equal to minus 162, 59, 25, 207, negative 72, minus 15, 42, negative 4, minus 11. That's the adjoint of P. Now, that's your adjoint. How much marks? 5 marks. That's not bad. It's worth the 5. Now this says, hence, we need to solve this system of linear equation. Now, I'm sure that's 8 marks. I don't know why they're giving away 8 marks. Because basically right here, this is solving P times our unknown matrix X equal to the result matrix R. But then we know X is equal to P inverse times R. And we know the inverse is 1 over the determinant of P times the adjoint P times the matrix R. So that's all. So now we're going to say, okay, XYZ is equal to 1 over the determinant, which is 183, times the adjoint. And the adjoint we said a while ago is this right here. Negative 162, 207, 42. So negative 162, 207, 42. And then the next one, the negative 167, negative 162, 207, 42. Then 59, negative 72, negative 4. Now we put 59, negative 70, negative 72, then negative 4. Then around here is 25, negative 15, negative 11. 25, negative 15, negative 11. Multiplied by the matrix R, and R is 11, 13, 4. Now we just go ahead and we deal with this like, we're supposed to. 1 over 183 times multiply the row and the column now. So we just multiply it across. Negative 162 times 11 plus 59 times 13 plus 4 times 25, and we get negative 915 here. So then now we'll go row and column again. Right, now you multiply 207 times 11 minus 72 times 13 and minus 15 times 4. You punch that in the calculator. you're getting 1281. Then we go 42, 42 times 11. Then we have minus 4 times 13. Then we have minus 11 times 4. Punch that in the calculator, we'll get 366. Now we multiply each by the 1 over 183. Let's divide this one by 183 first. We'll get 2 down here. C is 2. Then 1, 2. Why is this 8 marks? I have no idea. 1281. Then we divide that by 183. And we're getting 7. And then for the top one, negative 915 divided by 183. And we'll get negative 5. So those are your answers now. So your answers, you're going to tell them, therefore, x equals 5. Y is just 7. X is negative 5, sorry. X equals negative 5. Y equals 7. And Z is, of course, equal to 2. Now, don't listen to me. Always verify your answer. Whatever your answer is, go back in the equation above and verify it. So you know that 4 times x, so 4 times negative 5, plus 3 times your y value 7, plus 5 times the z value 2. You're supposed to get 11, right? So come see. We get 11, so no, correct. And you can verify with any of the 3 equations. Now once you verify you know you're correct, you move on. So part A, done and dusted. So this part now. Now this says Alex has 5 blue marbles, 4 green marbles, and 3 red marbles. In how many ways can he arrange 4 marbles in a row if the colors of any given, if the marbles of any color are identical, all identical. So if they're all identical, if we want it to be identical, then there are many different ways. You could remember how much marbles? You want to arrange 4 marbles, right? So we want all the colors to be the same. So in order for him to arrange it, 4 marbles in a row. In how many ways can you arrange 4 marbles in a row and get all of them to be of the same color? So we have marble 1, marble 2, marble 3, marble 4, right? And they all need to be the same color. Let's start with case 1. You know this is how I like to do it. Case 1. Case 1 now is, let's say him want all of them to be blue. So notice how many blue him have? He has 5 blue in total. 5 blue marbles. So in order to get 5 blue, right, this is 5 here, 5, and choose 5 of the blue. Now, then now, how much blue leave when you take out 1? 4, then 3, then 2. Alright, so that's it. So that's it. 5 times 4 times 3 times 2, and you punch that in the calculator. Alright, so let's do that. 5 times 4 times 3 times 2. That deal with blue, and that is 120. Alright. Now we have the case now where you need to arrange the 4 green marble then. So case 2 now, you need to arrange up the green. So for the green marble now, we need all 4 of them to be selected to be green. Alright. So basically, I'm gonna try alternative and see if in this case if we can just use combination, right? So what we're saying is we want to choose, we're choosing 4 green. We're gonna do a combination way and see if we're gonna get the same thing. Alright, just see, just test it. But with green now we know it's gonna be 4 times 3 times 2 times 1, and that is 4 times 3 times 2 times 1. I think that's 24. So 120 plus 24, that is 144. Now, notice I don't go red because you can't get four identical red. Here now, using combination, we're choosing what? We're choosing four of the blue out of five, and we're not choosing any. We're not choosing any green, and we're not choosing how much green? Four. So we're not choosing any green, and we're not choosing any red. Zero red from the three. So this would give us the guess one. Five twos four. I'm just testing to see if this is okay. Five twos four. Five times. So yeah, combination will work because it don't give you the arrangement. So yeah, it's a combination can work. Once you hear arrange, you know it's a permutation question, but combination will not help you. Please don't try and do permute. Please don't try and do combination. As you can see, it's not gonna be helpful because because combination the order does not matter, but with permutation the order does matter. Right? The order does matter. The order matters. So therefore, this won't give you the answer. That's it. Now we reach the easy part of the paper, probability. Probability here, they want us to find the probability of A complement union B complement. I love to draw like a Venn diagram so you can see what they're talking about. This is A and this is B, right? This is A and this is B. And you want A complement union B complement. Basically on the outside here. Because A union B is in here. So A complement outside of A, B complement outside of B. Alright, that's complement. So this is what they want. So the probability of A complement union B complement is equal to 1 minus the probability of A union B. Alright, and the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. Your thing. This is 1 minus probability of A is half, probability of B is quarter, minus 1 over 8. That in a calculator. So put that in our calculator, that is 1 minus, open bracket, fraction, 1 over 2 plus 1 over 4. Then we have minus 1 over 8. Close the bracket. We have 3 over 8. Done. Alright, that's it. 3 over 8. I'll move on. Nice. That's the only probability they ask. Yeah, that's it. Well, actually, the probability continue in question 6. So now they're asking us to do a conditional probability. The table below shows the probability distribution of a color blind men and women in the population where 51% is male and 49% is female. The event that a person is colorblind is A, and the event that a person is a male is B. Okay. So he is men and colorblind is A. Okay. Find the probability of A given B. Formula to use for conditional probability, just need to remember it's the probability of A intersect B divided by the probability of B. The probability of A intersect B. So look at it where A and B intersect, right? This is A, this is B. They intersect right here. So the probability of A intersect B 0.04 divided by the probability of B 0.51. I'll punch that in the calculator. Alright, so 0.04 divided by 0.51, which is 4 over 51. But don't leave it like that, give them the decimal since they're giving you decimal. That's 0.0784. 0.0784. Always give three significant figures. That's why I write it like that. Okay. Now that we have that out the way, what else they want? It says calculate the probability that a member selected at random is colorblind. The probability that a person selected at random is colorblind. blind. So basically the probability of A they want us to find. Now the probability of A is going to be, if a person is colorblind, it can be either a male is colorblind or it can be that a female is colorblind. So this is just equal to, let me write the formula. It could be is that it's a man and him colorblind, so colorblind and you're male, plus female and you're colorblind. So that's all. So the probability of A intersect B, we got that above was 0.0784. 0784 plus probability of A intersect B now. A intersect B complement rather, which is a female is colorblind. So female and colorblind, this is woman 0.02, right? So just to look back at the table, this part is probability of, oh, intersect B was not that. Why I put that? Sorry. Probability of A intersect B, as I did, was 0.04, 0.04, plus the probability of A intersect B complement was woman and colorblind is 0.002, 0.002. So now we just add them together and keep it as a decimal. 0.04 plus 0.002 is equal to 0.042. That's our answer. And done. Marks. Now it reached the best part of the paper, which is differential equation. Now, remember there are two types of first order. It's either a linear differential equation or it's a separation of variable. Now, based on this question, it looked like a linear. So linear, we want to get it in the form. Remember, it's dy by dx plus a function times y equal another function of x. So if we divide through by x squared, then dy by dx plus 2x over x squared is 2 over x. Y is equal to cosine x over x squared. So what I did, I divided through by x squared. Alright? After dividing through by x squared, I need to find my integrating factor, which is e to the integral of 2 over x dx, which is e to ln. When I integrate 2 over x, remember integral of 1 over x is ln x. So this is just 2 ln x. So bring up the power, this is e to the ln x squared. E cancel ln, so this is x squared. Then the formula when you're solving this is y times the integrating factor equal the integral of your function of x times your integrating factor with respect to x. So therefore the solution is yx squared equal the integral of cos x over x squared times x squared dx. Now the x squares are going to cancel each other. And so this now is very boring. It's just yx squared equal the integral of cos x dx. When you integrate cos, it gets sine. So yx squared is equal to sine x plus some constant k. They will divide through by x squared. So therefore y is equal to sine x over x squared plus k over x squared. But you need to find what k is. They gave us the initial value that when x is pi, the y value is 0. So we can tell them, okay, when x equal pi, we know the y is 0. So that means 0 is equal to sine pi over pi squared plus k over pi squared. Now sine pi is 0, so that means 0 is equal to k over pi squared. And if you anything times 0 is 0, so k is just 0. So this works out boring. And so therefore y is just sine x over x squared. That's the curve. Y is just sine x over x squared. 9 easy marks. That is very easy. I don't know why it would be this easy, but It's that easy. Sine x over x squared. Just to zoom out so you get the full page here. That's it. Y sine x over x squared. The next part says determine the general solution of this second order differential equation. So when we're doing this second order differential equation, oh my back. Ugh. What we're doing with this second order differential equation, first we solve the homogeneous part, right? So we're gonna be solving y double prime minus 7y prime plus 12y equals 0. Then get the auxiliary equation. We have u squared minus 7u plus 12 equals 0. In that case now, we factorize u, 4 and 3. Signs are the same, both negative. So u equals 3, u equals 4. When you get your two solutions, that means your general solution, or well, it's not really the general solution, it's really the complementary function. Let me write complementary. The complement, remember, this is a complementary solution. Right? So therefore, now our complementary function, I like to call it yc, is equal to e to the minus 3x, well, ae to the minus 3x plus be to the minus, is minus plus. Remember the formula is the complementary function is a e to the u1 x plus b e to the u2 x, or m1, whatever you want to call it. So a is just positive 3, so e to the 3x plus b e to the positive 4x, and that's it. Now what you can do when you're taking back these, you can check back these answers. You can differentiate it. You can differentiate it twice. Differentiate it a couple times, right? And you would realize that it works out like this, right? So that's our complementary function, right? And we need to find our particular solution, or now to find a particular solution, you have to look at the form that it's in. The form that it's in is sine x plus cos x, right? So in that case now, for the particular solution, right? So for the yp is equal to, use a different constant now, k sine x plus j cos x, right? Just want to go back up, sine minus cos, yeah. So that's okay. K sine x plus j cos x. So that means yp prime would be, differentiate this, when differentiate sine, you get cos, and then when differentiate cos, you get minus sine. Then when you differentiate again, when you differentiate cos, you get minus sine. When you differentiate sine, you get positive cos. Then we're going to substitute these three equations now. We're going to substitute these three equations in the original equation. So sub into the original equation, right? So we just plug it in where we see y and y prime and y double prime. So plug in y double prime as y double prime is minus k sine x minus j cos x. And then we plug in minus 7 times y prime. Y prime is k cos x minus j sine x. Then we plug in for 12y plus 12 times y, and y is k sine x plus j cos x. And that's equal to, now, that's equal to, equate it to, what they say it was again, sine minus cos. Go back, sine x minus cos x. So that's what we equate it to. Equate it to sine x minus cos x. So now you can always now expand out and simplify. And notice I have a minus k, I have a minus, and minus is really plus. Then I have another sign here. So with all the signs, I notice I have minus k sine x plus 7j sine x plus 12k sine x. That's equal to sine x. Can divide through by sine x when I equate the signs. So I have minus k plus 7j plus 12k is equal to 1. So simplifying, I have 11k plus 7j equal 1. Now I'm going to go ahead now and equate my cos. I'm just going to zoom out a bit so it's a little more clear. Equating my cos now, using a different color for the cos. Let's use this color. So we have minus j cos x minus 7k cos x plus j right there. So we have minus j cos x. Then we have minus 7k cos x. Then we have plus 12j cos x is equal to minus cos x. Divide through by cos. This is minus j minus 7k plus 12j equal negative 1. Group of like terms, minus 11 plus 12 is now 11j minus 7k equal to negative 1. So now in this case now, this is our first equation. This is now our second equation. I'm going to solve them simultaneously. So solving them simultaneously, just write back the equations. It's 11k plus 7j. I'm going to switch it around and say 7j plus 11k equal 1. That's the first equation. And the second equation is 11j minus 7k is negative 1. So 11j minus 7k equal negative 1. So let's just multiply the first equation by 7, multiply the second equation by 11. So that is 49j plus 77k equals 7. And this is now 11 times 11 is 121j minus 77k equal negative 11. I'm not so confident with 11 times 11, so I'll put it in the calculator. Yes, we're right, it's 121. Now you can just go ahead and do your regular addition. Add them. I can't add so well. 49 plus 121, that's 170. A equal 7 plus negative 11. As I said, I cannot add so well. 7 plus negative 11 is negative 4. So J is going to be, divide that now by 170, and we get minus 2 over 85. That's J. Once you find J, you plug it in any one of the equations for K. It's a lot of work. So 7 times negative 2 over 85 plus 11k equal 1. So that means k equal, just transpose it in your calculator. You don't need to show them transposition, right? So times this by 7, that gives us 7j. And remember, we need to bring it over now, so subtract it from 1. After you subtract it from 1, divide it by 11. You can do all of that mentally. That's 9 over 85. To write your final answer, therefore y is equal to, remember, it's a e to the 3x plus b e to the 4x. Then now plus our particular solution. Our particular solution was k sine x, and k is 9. So 9 over 85 sine x, and then now minus 2 over 85 cos x. That's it. Easy, easy, easy. Right? And so that takes care of this paper. I hope it was okay for you. This is 2022. Not as difficult as previous years. I was a bit rushing a bit at the end because, you know, I wanted to do this video from a long time ago, but just get the time, day before the exam. I'm sorry. I wish you all the best preparing for Unit 2. Hope it goes well, and that the paper will be very good. Right? Thanks for watching. All the best.